All right, welcome everyone to the 12th ROS2 Hardware Acceleration Working Group meeting. We're going to be treating as usual first and starting with all business and progress review. But before that, I just wanted to thank everyone for joining today. And specifically also, I would like to thank BJ Tenapareddy, who is professor from Harvard, who is joining us today and will be giving a speech on the second half of the meeting. A very exciting one, hopefully in a, I think, very not only exciting topic, but also something that's going to take quite a bit of work and discussions down the road. So stay tuned, and we're just going to give it to BJ in very few minutes. The participation for this event is, we're already past 40. It's going to be big, so we're not going to record every single person based on past experiences, which was lots of work. Instead, I just kindly point you to the LinkedIn event, wherein essentially everyone should be registered. I'm going to start by sharing my screen as usual, and also I'm going to paste in the chat the minutes of this meeting. So if you're following the meeting, feel free to open that up and, of course, share with us your comments. And let's start with the first topic. Updates from ROSCon and IROS on hardware acceleration. So we had a number of talks actually about hardware acceleration throughout ROSCon and IROS over the last couple of weeks in Kyoto, Japan. For those of you that weren't there and aren't familiar with these two conferences, they happen every year across the world, typically in a rotation manner. And they pack together hundreds or thousands of roboticists who share essentially their views on latest updates and research across various fields, including, across various sub-areas in robotics, including, of course, hardware acceleration. We had this year at ROSCon a talk named An Open Architecture for Hardware Acceleration in Robotics and ROS2, which was partially featured in one of the previous working group meetings. There's also a blog post in here, which, in case you couldn't make it to Kyoto, summarizes a bit of the speech that was given. So you can go through it, and I won't bore you with more details. You can read it, and then, of course, ask any questions or send us any comments. The recording of the talk, as usual in ROSCon, will be available. It's just going to take a bit of time for the corresponding company to process it and upload it, but stay tuned to that as well. So the talk overall was, I would say, rather successful. We had a very high attendance. Unfortunately, we couldn't take questions because of time issues, but overall, I think it's fair to say that we pretty much had quite a bit of excitement, and there were certainly lots of people that approached afterwards and asked lots of questions. So on that end, thank you, all of those of you who met or meet me there over the last couple of weeks. And also thanks to everyone sending good feelings, comments, as well as criticisms. That's helping us improve this working group and the work we're doing. So ROSCon very successfully encouraging everyone to consider joining next year. It is certainly a community that's growing and maturing very rapidly. This year it packed over 700 persons, very, very technical, but also lots of business around. Next year is happening in the US. So do consider joining. If you're doing hardware acceleration, we'll be there. IROS was definitely also quite interesting. We presented a talk over there that was the result of a collaboration between Harvard and Acceleration Robotics, as well as Klagenfurt University. And we also spoke about hardware acceleration and open architectures on how to enable this in a vendor neutral and technology agnostic manner. The recording is available and you can check it. This one was pre-recorded, so it is a short version of what was given, but nevertheless should get you up to speed if you're wondering what we shared in these conferences. Now, one thing that I'd like to bring to the attention of everyone is the fact that we did collect data specifically while at ROSCon 2022. We particularly asked the audience that attended our call, but also overall that participated in the conference, what do you care more about when it comes to hardware acceleration? And we got a total of 121 answers, which is pretty significant given the fact that we had about 700 participants in the conference. So quite happy about that. response rate. Of course, not everyone that showed up in the talk certainly answered, because I could count many more heads than those, but nevertheless, it's still representative, and it also aligns and helps further refine some of the past benchmarks we've been conducting in the community. And that's been summarized in here, in this slide that I put together to discuss with you all right now. The results on the left side, what you see right now is the results that essentially were produced after processing the input received from the survey that we conducted both in the ROS2 community and the robotics communities overall, wherein we asked the same question. However, we only offered 3 choices to the audience. And you can see that the spread follows with real time and speed or low latency being the ones that got the most attention. Now, when we expanded on that during ROSCon, and that's what you can see on the right side, we could observe how essentially as we provided more options, particularly as we are learning more and more, and as you guys are providing more and more feedback, it becomes obvious that there's more things than just the very few ones that we considered at the beginning, and how essentially we can see things such as power and bandwidth or throughput gaining also relevance, but still we can see the prevalence of real time being what most people demand. And this makes sense because, as we've been repeatedly saying over meetings, robotics and robots are real-time systems. Systems wherein essentially real-time and determinism is one of the most relevant characteristics. So that kind of like is very coherent with how we bring up and build robots. But certainly interesting to also see how about a quarter cares still very much about low latency, speed, and also how bandwidth and power certainly are of relevance. Specifically, I must admit that I'm personally, my personal belief is that power is going to grow over time. I think still only 10% cares about, getting computations with in a power conscious manner. I think this is going to increase over time as people realize that mobile robots are actually very sensitive to this, but we'll get there. So yeah, these are interesting results that I wanted to share. We will be conducting follow-up surveys, possibly next year. I don't think we're going to annoy any of you again anytime soon. But nevertheless, once again, thank you to all those of you who participated either in the survey a few months ago or now during ROSCon answering the poll. That was fantastic. And I'm also super happy to see how there seems to be some conclusions we can certainly take out of this, and we'll be continuing with this effort. Now, connected to this community surveying effort is the standardization efforts that we've been pushing as part of this ROS2 hardware acceleration working group, which essentially boil down to 2 ongoing community standards. For those of you not so familiar with the ROS ecosystem, within the community, there is essentially community approach to define standards on how things get done or should be done in robotics. These are called REPs, or ROS enhancement proposals. And these REPs essentially live in ros.org/reps, and in here you can see the index. So there's a bunch of them that have been created historically. You may not like the format, but actually it works fantastically fine for what concerns defining this. It is pretty easy to extend and create new ones. And so you can see a number of them. We've been working now for a few months on trying to define those that are relevant for hardware acceleration purposes. And those ones, again, live in those 2 ones that I linked in here. The first one, which we have reviewed repeatedly, is a rep whose title aims to define a series of hardware acceleration reference architecture and conventions. And you can read about it, provide feedback. It's still open for it, and the conversation is still ongoing. There's been many reviews, and note that this has been going on for more than a year now. So you will be landing in a document that has received quite a bit of feedback already. But please dig on it. Don't be shy, and do feel free to send any input you may have. The second rep is a reasonably more fresh initiative that aims to complement Rep 2008, which defines conventions and a reference architecture for hardware acceleration. And this one focuses on defining how benchmarking performance should be done in ROS2 and specifically across ROS2 nodes and computational graphs. For a bit of context, this was originally part of Rep 2008, but then after a series of feedback, we decided to branch it out into its own document, wherein we extended further the principles, why it's so important, and essentially how we recommend this should be done. It's important to highlight that this Rep, as opposed to the previous one, which is a specification, this Rep 2014, it's informational. This means it does not aim to be setting any conventions. It's not a specification, it's just an informational Rep. So essentially the impact it will have will be still relevant, but still you may choose to do things differently while still complying totally with ROS2 principles. There's here motivation and rationale on why this is so important. I just want to spend 1 or 2 minutes highlighting the fact that the ROS2 community right now is very fragmented, both in terms of the ROS2 distributions, but also in terms of even stacks itself, manipulation or navigation. It's often complicated to find alignment across the uses of the same package across various stakeholders, various vendors or manufacturers of robots. So this of course further complicates the reality when it comes to comparing apples with apples, and that is why this Rep tries to somehow shed some light into how to do so in a vendor neutral and comparable manner. Again, the value for stakeholders is described in there, and it does propose to follow a strict quantitative approach by essentially integrating tracing, particularly low overhead real-time capable tracer. It's leveraging LTTNG, the Linux tracing toolkit. For those of you that aren't familiar with this, it is a open source project that's extremely influential, that is used to instrument many software packages, that is of extreme low overhead. That means that you can instrument a piece of software and that you can enable or not the trace points. If you disable them, the impact is negligible. If you enable it, the impact is actually extremely small, and it still can provide real-time responses. And there are papers that are cited in the references at the bottom of this document that give you further insight into that. I wanted to spend just a few seconds further emphasizing that the approach that's suggested in this document helps us collect both functional, but also, and that is the focus in here, non-functional data about running robotic systems, running ROS2 systems. That is information about the latency, its throughput, memory, power, etc., in a gray box manner. That means that we don't need to create an artificial test application that then we run to collect the data. No, we actually instrument the real application, the ongoing real application that can run on simulation or on your target physical robot. And while this application is running, it is generating data throughout each one of these probes. This data is landing into a file, a physical file that's in your root file system, and this is happening all with a tracer that's specifically designed to do this, not C++ or Python custom-made or third-party libraries that often the case include or impact significantly your application. No, this is made and thought to be made with, again, tools widely used in industry and across time-sensitive industries, I'd say. So just wanted to emphasize that, particularly in the context of the fact that there's lots of prior work of doing benchmarking in the ROS2 ecosystem. It does appear that each new lab that wants to look at the performance of ROS2, or at least it used to be like that, they created their own fork. And so we did a bit of literature review. And you can see in here in this document how, well, there's a bunch of forks of forks of forks that then ended up adding value. Certainly, each one of them does add something different, but nevertheless, coherent approach would have certainly done something better for the community. And that's hopefully what we are trying to get in here for what concerns hardware acceleration, as well as overall getting performance benchmarking of any robotic application in a stack agnostic manner across manipulation, navigation, autonomous mobility applications, etc. So anyhow, encouraging you to go through this document. Rep 2014 is definitely going to be highly discussed it is now a good moment actually to dig in and maybe try to make enough contributions so that you can be part of the authors leading this. And also a word of thanks to a few folks that have been giving quite a bit of review, particularly Christoph, Bedard, and Ingo. They have been very helpful reviewing this. So thank you guys if you're listening to this now or in the future. And yeah, with that, I think we do cover the standardization efforts so far. There is minor updates regarding some of the projects of the working group, particularly the Robotic Processing Unit and the Robotics MCU. But I think for the sake of time, I'm not going to speak too much about that today. I'll only say that there is very exciting work that's ongoing in the background about trying to push out a complete block diagram of the Robotic Processing Unit, which hopefully might be ready for the next meeting in December. And also that for what concerns the Robotics MCU, which we discussed in previous meetings, we are right now working with a rival to try to come up with a further narrowed down use case to drive the development of this open source software and hardware microcontroller unit for robotics powered by RISC-V. This wasn't originally part of what we had in mind when we kicked off the project, when Plan B and us at Acceleration Robotics kicked it off. But the reality is that it came on the way. It came actually out of the working group, which, as you can see, we're taking feedback very seriously. And frankly speaking, I can only say I'm shocked and excited to be working right now with a rival to try to bring this into the project. We are very excited about what this can lead to, because if we manage not only to show a proof of concept of a robotics MCU that is going to be a first-class participant of the ROS2 ecosystem, but also one that actually serves to fulfill a use case need that right now exists in robotics that other microcontrollers can't, I think will fulfill various objectives simultaneously. So yeah. Stay tuned, and also hoping to bring news about this very, very soon. With that, allow me to just bring you up to date with a few updates regarding new business over the last few weeks since the last meeting that happened in September. There's been some recent stuff that has been published. The first one is we've finally made available the 2022 Hardware Acceleration Report in Robotics. This is something that's been going on for a while, that we have been reviewing, that some of you have been actually acting as reviewers. So thanks again, those of you that sent feedback and comments. The document is about 64 pages. We're not going to cover it all today. I'm just going to give you essentially a quick peek into what it does touch on. And as we said in the past, the document itself essentially is partitioned into 2 to 3 big blocks. The first one that does report on the community survey that we conducted. A second one that, based on that community survey, builds a series of benchmarks that reports on the actual status of hardware acceleration and computing in ROS2. And then there's a discussion section at the end that does take some conclusions based on the data and results that are generated. So I'll leave that to you to further review it, and skip that to the last section of my introduction today, and I want to hand it to BJ ASAP. So I'll just say two quick more things. The first one is that we're going to have a session in December. It's likely to happen around mid-December. The date is still to be specified and will be announced both in ROS Discourse and LinkedIn as past ones. I'm excited to say that I think we have closed a reasonably exciting guest speaker that will be touching on essentially a CUDA enabled or accelerated implementation of a simulated LiDAR. And that'll be touched on next session. So stay tuned for announcements regarding that. Just wanted to give you a heads up because I think that's going to be exciting. And this person's coming from Robotech. So yeah, a good company to definitely follow as well in the domain of hardware acceleration. Last topic I wanted to introduce is, and that's going to be further touched by BJ, but I just wanted to give you a heads up. We haven't yet announced much about this in this course or in social media, But we are very excited to be essentially pushing forward something that we call RobotPerf, which is a benchmarking suite that is going to be used to evaluate robotics computing performance. That, of course, includes hardware acceleration capabilities. RobotPerf also is going to aim to not only provide a suite that you can use to generate baseline performance results on your own research, but it's also going to aim to become a consortium of robot leaders coming from academia, research labs, but also from industry. And the ultimate proof about industry relevance is the fact that we at Acceleration Robotics are very involved on it and leading it from the get-go. The mission itself of this consortium is going to be to build fair and useful robotic benchmarks that are technology agnostic, that are vendor neutral, and that provide unbiased evaluations. That's in a nutshell what we're going to be aiming for. And yeah, I've just pasted in there a link to right now the current ticket that is tracking the definition of RobotPerf. So you have a few more details, rationale and motivation over here. I won't steal you more of your time. You can touch on this on your own if you want to. The main objective of this is to provide a site right now where you can express interest if you want to. So you can drop a comment in here. Of course, you need to authenticate yourself. But I think that's the least we're expecting for people who wants to participate. And yeah, express your interest, maybe mention which organization you come from. Again, this is not a project we're leading on our own, but in collaboration with BJ and his team. So he'll tell you more about the whys and the hows right now, but just wanted to make everyone aware about the fact that we're taking this very seriously, that we're investing resources, that this is going to be a big chunk of the work we'll be doing from right now and into the following few months. So stay tuned. This is also very connected with REP 2014, which we reviewed, and much work that we've been pushing out, including RobotCorp. So yeah, very excited about this. And with this, I think it's fantastic to introduce Professor Vijay Janapa Reddy from Harvard University. Vijay, for those of you that don't know about him, and I don't know if he will mention it, but Vijay is actually one of the persons behind ML Commons and ML-Perf originally, which then drove to all this big benchmarking effort in machine learning and artificial intelligence. So he is extremely experienced about how to put proper industry benchmarks in place. He's been working with both academia and industry. He's definitely the right player and has been also doing lots of work benchmarking robotic systems. So with that, BJ, the stage is yours, and super happy to have you.
Awesome. Thank you. And I trust you can hear me well?
We can.
Awesome. Great. All right. Okay. Awesome. Good morning, good afternoon, good evening, wherever you folks are. It's a pleasure being down here. So today I'm excited to talk about what Victor was kind of mentioning about, which is RobotPerf, which is effectively around understanding systematically how robotic systems are performing. Now, I'm going to talk a little bit about what benchmarking is. You know, it's a word that we're often familiar with, but I want to actually dig into it and explain what benchmarking is and why it is actually extremely critical. And then I want to use some existing examples to help you understand that if we can build a robust benchmark, how it will actually accelerate the field, which I think is really what we want. And we need that field acceleration if we actually want to see robots outside the door. I often like to tell roboticists this. You guys have been working on this thing forever, and yet when I open my door, I don't even see a simple little robot outside. Why is that? I think there are many good reasons for that. And I think one of the big reasons is a lack of systematic methodologies to assess things, which systems people like me, have been working on for a very long time. So there's some lessons to be borrowed across the fields. And I want to give a big shout out for Victor on this as well, because Victor is sort of integral in helping kind of think through why we need this and so forth, and as you can see from the reps. And today's presentation, I'm going to be splitting it with my research assistant, Jason, who's actually on the call, and midway through, he'll actually take over to help explain how we're doing this. So first, let me start off by talking about what is benchmarking and why is this important. Benchmarking as a fundamental science becomes important whenever the field is at a critical junction. Now, critical is the key term where the technologies have kind of matured to a point where really it's an intersection of these different technologies that are needed are starting to click together. And whenever the community is trying to click together, there's often a lot of confusion because people are coming from many different dimensions. And so what you really want to do is kind of give them a beacon or a lighthouse where they can point to and understand, how do I get to that beacon or, or sort of a lighthouse? If you're familiar with the DARPA challenge is sort of very similar to what benchmark is. DARPA gave this grandiose challenge. They said, okay, well, try and get these, autonomous robots to work in a XYZ way. That gives a very clear focus to people, and people can go out and, obey the rules and kind of understand how to solve that problem. So that's fundamentally what benchmarking really is. It is a standard or a point of reference against which things can be compared or assessed. Why you need this comparison or assessment is really because you want to have different solutions. You want to encourage the community or the ecosystem to thrive and develop new and different types of solutions, but you need to be able to compare them. Otherwise, it's like saying apples are comparing to oranges. I don't even know what the hell that means, right? They're fruit, sure. That's like saying, yeah, they're robotics, but that doesn't really help you understand, if one apple tastes better than another apple, right? So that's why benchmarks are sort of critical. If you can build a good benchmark, which typically involves, having a set of code, a set of rules, a clear set of metrics, the three pillars of any benchmark, then you can use that to systematically compare different solutions that you might be getting. And if you can compare solutions, then you can make informed decisions. For example, is RPU A better than RPU B, right? And if you can do that, then you can actually measure and track progress from one generation to the other. Now, I'm going to give specific examples down the presentation later on to help you understand why, if we build a benchmark for a new and nascent field, you can truly measure progress. Ultimately, the goal is to raise the bar and advance the field. However, if you want to do this, you cannot simply sit in your room or sit in my lab and say, okay, how about we kind of like think about what benchmarks are needed in order to drive the ecosystem forward? If you actually want to do this, we really have to develop a systematic and rigorous methodology. Now, this methodology is hard to kind of build when you kind of think about it in isolation. What you really need is community-driven support and activity around this. You need the collective wisdom of the entire community, because people look at things in many different dimensions. You want to be able to tap into that in order to build that benchmark. And if we can do that, then we can actually standardize which use cases are important. What are the most important things to actually measure? What are the workloads? For example, we can say ROS, but ROS is a big ecosystem, right? There are many different bags, and which ones do you look at and so forth. If you have that community involvement, you can actually figure out what those workloads are going to be. That means then with those set of workloads, you can then compare solutions that are coming about in this ecosystem. And that comparison will actually create a competitive environment that actually fuels the actual field. So we can effectively do complex characterization of systems to understand what things to improve. And ultimately, though, if you come to my room and say, hi, I've got a system that does really well, if you have a good benchmark, you can say, okay, well, if you are able to run that benchmark, it tells me something about what your capabilities are, right? It gives you that level of transparency that's actually quite critical. So let me kind of ground these principles in the past. Benchmarks are nothing fundamentally new to the systems ecosystem. There are existing benchmarks. So I want to give you a little sneak peek of a bit of a history to help you show how these benchmarks can actually accelerate the field. If you consider the processor that your computer has, right? General purpose CPUs, things like Intel and AMD build. Well, this community, if you date it way back, the field is about 50 years old, but it's like, if you actually date it back to their inception years, there was a lot of confusion about like, hey, which processor is actually better? What aspect of the processor is actually giving you better performance? Is it the software that's actually being optimized better by the compiler that's actually giving you the hardware performance, or is it actually the microarchitecture? Sounds very simple today, but if you actually kind of think about it, it's quite complicated, right? Because you have to understand what you're trying to measure at the microarchitecture. Then you have to understand, okay, what code do I run? What code, if I run, is actually representative in terms of stressing the processor in certain ways? Then what's the role of the compiler? What are the elements that you can actually freeze, right? So spec benchmark has been around for a few decades, and it actually helped drive generational improvements in processor performance, right? And some of the key goals there have been, how do you enforce performance replicability? How can I repeat results easily? This is not about verifying or validating people's results. It's really about building on the good work of prior work, right? And you want to understand what are some representative workloads that if I study workload A, even though my workload in my entity is actually a little different, it actually gives you a lot of perspective into how the machine will actually perform. Next, you want to encourage innovation. That's exactly what spec did. It drove the state-of-the-art CPU improvements from one generation to the next. It also allows fair and useful measurement. You actually measure things that actually tell you something interesting about what is actually happening in the system. And you want to keep the commercial and research communities working together, because if you want innovation, you have to have that research element integrated in there. And you want to keep the benchmarks affordable. All of these were principles of what SPEC did in order to drive where we are with today's Intel and AMD processors, for instance. If you look at machine learning, which has come about more recently, not in over decades, but in like about the last 7 years, where it really took cement. If you kind of look at that space, well, we needed a new benchmark, and MLPerf is such a benchmark, where, for example, we want to build high-performance machine learning systems, similar to what we're trying to do here, build high-performance robotic systems. We have to figure out, machine learning brings around code, so it introduces a whole new dimension of what measure, right? So you have to understand what data are you going to freeze, how are you going to actually deal with the neural networks and so forth, and build a benchmark. So just to kind of help you understand like how we're going to go about potentially building this, robotics RobotPerf benchmark, I want to talk a little bit about some of the nuances around building a benchmark. So, okay, MLPerf is a suite of benchmarks similar to what RobotPerf is going to be. But how do you build something like that? Well, you have to deal with large public data sets because it's a community-driven activity. Whatever we do has to be in the public domain. You take that and then you build specific benchmark for specific aspects that you're trying to measure. In machine learning, you often have to train a model before you can actually use the model. So you have the notion of training the benchmark. How hard, what do you actually stress when you're trying to train a network? In inference, where you're just using the network, there's a different set of metrics that you actually want to capture. In order to build this pipeline, you have to identify what are some key tasks, for instance. Is it perception, planning, control, localization? What is it that we actually care about, right? There are lots of things that happen in the robotics pipeline. So what are those tasks we care about? Then we need to understand how are the systems actually exercised. It was interesting to see what Victor was talking about earlier, where emphasizing real time was sort of a critical thing. So one might say, if you talk to a traditional processor architect like me, I would say, oh, just look at throughput. My machine is able to crunch X amount of frames per second or something, but that's actually not a real time metric, right? And that becomes critical by understanding where and how these robots are going to be deployed. In machine learning, it's about how machine learning is actually being deployed. Then identifying a clean set of rules. What do you measure? When does timing start? When does timing stop? And effectively capturing the right set of metrics that actually tell us something about something interesting that we actually care about at the end of the day, right? And of course, being transparent. We want to make sure the results and how data is being collected is all transparent, because that transparency is what is going to allow us to move forward. Now, if you want to build something like this, you can't simply just, cook it up in a lab, right? You really have to bring the community together. So in the context of ML, what we did was we brought the industry together because there was so much excitement around ML. In robotics too, there's a wicked amount of excitement, right? A large number of companies, exactly to Victor's point, ROSCon and so forth, and IROS, these are big conferences, lots of people. The industry is really cooking towards this. So similar to what I'm showing down here, I think there's an entire parallel mapping of the different companies that are interested, some potentially overlapping here. But if we can gather this community together, then we can actually build interesting benchmarks, which have certain key characteristics. So for example, a benchmark would cover many different areas in machine learning, for instance, vision, language, and so forth. You'd have different kinds of machine learning tasks or robotic tasks in our instance. Would have different specific scenarios that we actually want to evaluate. So we have corresponding data sets for that, like, what's the input feed? We need to have certain key metrics. It's not about just performing a task, right? It's a question of how well you perform the task. In machine learning, for instance, it's very important to get the accuracy right. So we specify certain targets, and then we provide reference implementations that you can actually just run. You do the same thing for inference. I'm not going to get into the details. It's the same fundamental point. You want to scour the wide space and then distill it down. And one of the reasons the community is actually very important here is because robotics is used so widely. So you have to tap into the community to figure out how can you distill that wide application space into something quite narrow, because you're not going to be able to run every single potential application and every variation on a system to understand how all the system's going to do. So this begs the question of how can we subset it? And that's why the community aspect becomes extremely important. Now, earlier on, I made this critical point that if you can measure something, you can actually make improvements, right? Just to show you a quantitative thing, as something that is evident, like in the last 4 years, through this MLPerf benchmark, just using that as an example again, each of the dots shows generational benchmarks, right? So imagine every 6 months, we're collecting state-of-the-art data. Then what we can see is across different tasks, we're seeing substantial improvement. Originally, it was 4x improvement just based on software and hardware. Then it went up to 8x. Then it went up all the way to 30x, right? So the point I'm making is if you start to measure and you have a core set of tasks that are rock solid, then you can actually systematically make progress. Much of this progress came not only from hardware innovation, it also came from software innovation, because people understood that there was this beacon, which is the benchmark that they really wanted to knock out of the park. And so it's extremely useful to actually do the benchmarking. Similar thing on another suite of workloads. You see radical improvements over multiple generations of the benchmark. I'm just trying to tell you that it's a general thing that you find that if you're actually measuring progress, then you can actually get progress. And once you start building that sort of a coherent mindset, you can actually create an organization that supports these activities, right? So here for ML, it's like ML Commons, a bunch of different companies that all care about machine learning have come together. Can we do something like this for the robotics kind of space where we have both academia and industry collaborating together? I'm an academic. I'm very interested in this space. There are plenty of academics who are very interested in hardware acceleration for robotics, right? So can we create that community together? If we can do that, we can really build a robotics consortium that aims to accelerate robotic innovation for everyone. Think of it that way, right? So I gave you this notion of how we can do this in the past. We've done it for ML-Perf, we've done it for spec and so forth. So the key question is, can we adopt the principles and the success that we have seen in some of these existing benchmarks and bring those lessons over to the robotics domain, right? Where we can actually reap some of the core principles easily. We don't have to reinvent the wheel. We'll have to adopt it, and then we'll have to adapt it in order to meet some of the unique characteristics. So with that said, I'm going to turn it over to Jason, who's going to dig into some of the specifics around how we want to actually go about doing this. Jason, I'll let you screen share.
All right, thank you. Let me share my screen here. All right. Can you all see my screen?
We can.
Okay,
yep.
Awesome. Okay, cool. So thanks, Vijay. Now that we have a good sense about how machine learning has benefited from benchmarks, let's take a look at the field of robotics, and maybe we can see how a benchmark in the field of robotics could accelerate this field and fill in some of the gaps that we see in robotics. So before we start thinking about how we can organize RobotPerf, the benchmark we're trying to build, it's important to think about the characteristics of a strong benchmark. What makes a benchmark strong? And as we were thinking about this, we came up with 5 key characteristics. The first one is listening to the community. What does the robot community value the most? What are the challenges that we're facing right now? The second characteristic is evaluating the correct metrics, picking the right metrics. What are the metrics that are slowing down the field? Where are the bottlenecks? The next characteristic are looking at the appropriate tools. What are the tools that are used the most frequently by roboticists? What's most important in those tools? What kind of kernels should we look at? The next characteristic is applications. A strong benchmark should look at a wide variety of applications because some bottlenecks could occur depending on the different tasks that you're looking at. And finally, a strong benchmark should be automated, or what I mean by this is that it should be reproducible, allowing different members of the community to contribute and improve the benchmark. So now that we have an understanding about what makes a benchmark strong, let's take a look at the first characteristic. So let's listen to the robotics community, and let's do this through the acceleration robotics report that Victor was speaking about a few minutes ago. And throughout the next few slides, I'm going to be picking a few of the interesting results from this report and trying to use it to help guide how we can construct this RobotPerf benchmark. So looking at that second characteristic that makes a benchmark strong, we have to pick the right metrics, the valuable metrics. And so the report asked the community what they care most about. And here are the results. Victor briefly went over this a few minutes ago, but a great amount of the community values speed at 48%, and then at 46%, the community values real-time determinism, and a small subset values power consumption. Another report was conducted at ROSCon, and it showed pretty similar results, where speed and real-time was something that was very valued by the community. Also, bandwidth and throughput was valued at 17%, and a larger chunk of this community valued power consumption. So let's distill this down into actual metrics we could incorporate into our benchmark. And it could look something like this, where we have a metric of latency. So how fast can tasks be completed from start time to end time? Throughput, how much work can be done in a certain amount of time. Real time is can task meet its deadline. Determinism is how reproducible is a computation. And finally, power. Even though that the community doesn't seem very excited about this metric, it's actually a very important metric to evaluate in robotics. Okay, so now that we've covered some of the strong metrics in robotics, let's talk about some of the widely used tools. So Victor and his team compiled a list of all the companies that have kind of explored ROS or had a project related to ROS. And they found more than 100 companies have, had some sort of relationship to ROS. And as I was going through the list, I started seeing some really big names like Boeing, Intel, Nissan, Honda, and the list goes on. So it's clear to me that ROS is commonly used within industry and academia. It's a common baseline. And ROS was built so it can help the community easily and quickly develop robotic applications. But what it's failed at is prioritizing performance. And that's kind of where our benchmark can come in. All right. So if we wanted to consider a framework like ROS, it would be important to consider the specific kernels inside or the components of ROS that are important to the community. So again, the report asked a question to the ROS community, and we see results as such, where about 60% of the community would like to prioritize the Gazebo physics engine. But the number one component is the ROS perception stack. There were other components of the robotic pipeline that were also highly valued by the community, which is the navigation stack and the manipulation stack. So let's look at the robotics pipeline. So we have, of course, perception, planning, control. Perception refers to reading data from sensors and inferring information about the robot's state and its environment. Planning refers to calculating a path between the robot's position and some goal. And control is calculating the optimal dynamics to control the robot's actuation. So within each part of this pipeline, there are specific kernels that are used for specific tasks. And what would be interesting here to consider is how the interaction between these kernels cause bottlenecks. So you can imagine how these kernels would be running simultaneously. Some of these kernels would be running simultaneously, so they would compete over resources and, of course, cause some sort of bottlenecks, which would be pretty interesting to study. I also was interested to learn about what kind of hardware acceleration is being used by the community. And again, another question was asked by the report, and it showed that about 70% of the community is planning to use or is currently using a GPU, while 22% of the community is planning or currently using an FPGA accelerator. So there is a strong push by the community to consider these hardware accelerators and potentially get better speed or real time or determinism out of these accelerators. So if we look back at our robotics pipeline, it would be cool to ask the question if we can take it a step forward and see how the bottlenecks change between hardware architectures. If we have a GPU, FPGA versus CPU, how would the bottlenecks look between those different hardwares? Okay, cool. So we've covered some of the important metrics, some of the important tools in robotics. Let's take a look at widely used applications. Again, another question was asked, what kind of robot are you creating? And this is a little hard to read, but the top 4 categories were industrial mobile robots, UAVs, industrial arm robots, and light robots. So if we go back to our benchmarking methodology that we're creating here, we can take it yet another step forward and consider how bottlenecks might change between different tasks or use cases. Of course, each different task would use a different stack of kernels, so it would be cool to study how that changes. All right, there's been some great work already in the field of robotics and benchmarks they've created. RTRbench considered specific kernels in robotics, and it evaluated different bottlenecks in specific kernels, but it didn't look holistically at a robotic system and the end-to-end system of all the kernels competing over resources and how that could change bottlenecks. MathBench specifically presented a benchmarking suite for micro aerial vehicles. And RobotCore, although it's not a benchmarking suite, it's moving the field of robotics forward by helping integrate hardware acceleration into ROS2, which is awesome. As Victor spoke earlier, currently there's a lot of different types of hardware, a lot of different types of software in robotics, so it sometimes is hard to create effective benchmarks. So I highly encourage you to take a look at the standardization effort that Victor is creating, and help input some ideas there. All right, we've talked about metrics, tools, applications, and lastly, let's take a look at the automation section. So our long-term vision of this RobotPerf benchmark is to create a leaderboard, kind of similar to the AI benchmark. The AI benchmark has a continually updated leaderboard that evaluates AI performance on different types of smartphones. So we envision something similar for RobotPerf. All right, thank you so much. Please feel free to contact us with any questions. Yeah, thanks.
That's awesome. Thank you so much, PJ and Jason. Fantastic presentation. In a very, very, I would say, very timely moment, since the discussions around benchmarking are getting heated in the community with essentially various players very interested. So I think we have time for Q&A, everyone. I do have questions, but I'm sure many of you do as well. So yeah, feel free to ask PJ and Jason anything you'd like to. Feel free to raise your hand or go at it directly.
Hi, this is Robert Anderson from MathWorks. And yeah, these were fantastic. Thank you so much. Great overviews, very, very informative. I had a question, maybe a little naive. If real time is achieved, is quote unquote speed still relevant outside of our target real time requirement?
So I'm kind of curious, I'm not following that question, Robert. I understand the real-time aspect. I'm not following the speed aspect, if you could help clarify.
So speed was one of the underlying parts criteria. So there was throughput, bandwidth, speed, latency, real time. And when I looked at it on the surface, it almost looked like they're sort of, if I hit real time, why do I care about how fast it goes?
Yeah, I totally understand what you're saying, and that's a great question. So I think the distinction there would be maybe it is fast, and like the speed has been increased, but the number of times it completes before the deadline might change. So maybe there could be some it would be valuable to look at how often does it reach a deadline. So there could be some stochasticity there, where it performs very quickly, but then how often does it go out of bounds and then not complete before a specific deadline.
Got it. Thank you.
So maybe I can add a few bits on that, and also I will echo Jason's words. I think it's a great question, Robert. So thank you for launching it. It's a tricky one as well. I can tell you the following. I think your real-time requirements can change if you have a speed. That's what I can say, and I'll elaborate a bit on this. So if all you care about, and often the case in robotics that it is real time, if you guarantee that you're meeting your deadlines, then of course your robotic system is going to perform at a certain, let's say, behavior, predefined behavior. So you're going to be good, right? And you will have a robust robotic system and so on and so forth. But the moment you reach that situation, you're asking us and you're asking everyone in here, why do I care about speed, about lower latency at all, if I'm already like meeting my deadlines, right? And I think that's wherein the higher performance speed comes in. If you're actually able to deliver way lower latencies, you can change your deadlines. You can have your system actually become higher performant. And then your real-time deadlines or your real-time requirements can actually change. And that's possible thanks to the fact that you do have speed. So I would argue you still care about speed, and you will. That's just a biased thought.
Oh, thank you. Yeah, those are wonderful answers. It's got me to think pretty deeply about what this really means.
It is often troubling to, and I often find myself sometimes confused. Determinism, real time, throughput, latency, often the case get intertwined, and actually getting the right definitions out there is, I think, going to be big work or a big part of the work of RobotPerf. So hopefully you guys can help us getting that done. Yeah, I agree with Raisa. I think this is right. Definitely adding more functionality and extra time is quite on spot. Yeah, very true. More questions for our guest speakers? Go for it, Miriam, please.
So yeah, hi, I'm Miriam Lisa from Northeastern University. So also great talks. And I think that I think the benchmarking effort's a really great idea. So, but I am going to put a little bit of a damper on it. So I find that when you do have benchmarks, people design to the benchmark, and it hampers originality and, you know, sort of research to some extent. And that was certainly the case when spec first came out, that people tried to improve what was being measured, and it put a damper on other avenues of research. So I don't know if you want to comment on that, but nothing's ever, you know, 100% good, basically. There's always trade-offs.
Yeah, I'm super excited that, you know, someone brought it up. I was wondering myself whether I should bring it up. So I'm excited. Only academics. So yeah, benchmarks, you're spot on, Miriam. Benchmarks, there's a good side of them, there's a bad side of them, and there's a really ugly side of them, right? And so I often feel like, you know, there's a time when we really want benchmarks, because benchmarks allow us to align the community together, right? So I do think that, you know, if we get caught up in, once we create the box and we tend to stay in the box, and it's really, really bad. I agree with that. But I think like right now, for instance, is a really good time to get that clarity around what are the common tasks, what are the base functionalities that we really just have to knock out of the park, so we can actually focus more on higher level cognitive tasks, if I may say so, in the robotics domain. So that's why I feel like now is a good time to kind of do such a benchmark. But again, even when you craft the benchmark, you do want to leave room for innovation, right? So you don't necessarily want to benchmark a specific kernel. Now, there are good reasons to benchmark a specific kernel, right? Like I might say, okay, this specific variant of SLAM is something I care about, a VIO is something I care about. However, you might also just kind of want to generalize and say, okay, well, I just want to do the SLAM task at large, and say how you do it as a combination of hardware and software is a solution, right? You want to leave that room within the benchmark. And spec is different in that sense, which I agree with you. It's like, you know, it's a set of ones and zeros that are given to you, and then you run exactly that thing, and there's no room for any extra creativity. So it does kind of inherently limit that creativity you're talking about. However, like for example, in the ML case where the field is still evolving, we knew we couldn't draw the box too tight. And so in that case, we allowed for the task definition, but we say how you do the hardware software co-design, for instance, we can leave open. So first and foremost, I do want to acknowledge that, yes, there's, you know, benchmarks can result in benchmark engineering, but I also think like the good side of it is that we get the clarity at least at this time. And I think at least for the next few years, until we get that clarity, the benchmark will serve its purpose. And after that, don't worry, you and I can jump all over this benchmark and be like, you industry people are not thinking far and you know, ahead enough. That's why we're here. We like to light the fire as academics and run for a while, and then then we like to tell them about what they need to improve next.
So that is a fantastic view, and also a fantastic question, Miriam. Thank you so much for bringing it up. Maybe I can give a bit of insight on why we industry people want it so much right now. So besides what BJ did share about the fact that there's definitely a big need in the field of robotics right now, there's currently I would say interesting dynamics in the robotics ecosystem where we are seeing how various silicon vendors are jumping in, and we at Acceleration Robotics are working and serving various of them, and we can tell how they in many ways are actually often the case a bit lost, and also the users on how they should compare themselves and even how they should aim to improve and invest resources to help people use these solutions which can improve robotic systems. And what we are realizing is that there is currently a specific trend to use certain solutions which have been over marketed. There's a huge amount of marketing towards certain solutions, which when you use them in real production systems, in real robotic systems, you do realize that you very, very, very soon reach edge cases, well, not edge cases, actually cases wherein they can't do more than what's being marketed pretty much. And so they become pretty much unusable in a way. And we have realized that, and we are seeing that increasingly, and that's leading to disappointment with what concerns hardware and hardware acceleration. So from an industry perspective right now, benchmarking and this effort, hopefully supported by all of you, is also going to hopefully shed some light into creating a fair competitiveness environment for actually comparing hardware solutions. Because frankly speaking, right now it does feel that people is just reporting on what they want. And frankly speaking, some groups are just reporting on throughput, claiming that is all you care about, wherein in many cases in robotics, we do care about very, very different things. So setting some sort of like common sense on how various players speak about performance in robotics and in ROS too, I think is crucial. And also this is in a way also a community tool to fight out these big companies, which often the case have lots of resources for marketing, and certainly don't allow individual researchers, whether from industry or academia, to actually showcase their results. And we do believe this is definitely going to open up that door. One final comment I can add, which you may or may not disagree or agree, and I'd love to hear reactions about this final comment, is actually transparency. And BJ mentioned this, and I actually have a question to him. One of the things that we are concerned about is that there seems to be a discussion around whether benchmarks should be conducted in an opaque manner, meaning that a source code that's being tested should or should not be shared and disclosed. And maybe actually this can open up the discussion. I can just leave it there. But what do you guys actually think about the need to actually have the actual source code to compare apples with apples? Is there any comment or reaction around this?
I can jump in just from experience. I can say that you don't necessarily want to have source code. In some cases, the source code is the IP of that particular company. Now, that said, you don't want, to Miriam's point, you don't want benchmark engineering happening under this magical black box that's custom tuned for RobotPerf, for example. And while the real stack is completely different, and it's we know how benchmark can go. To address that, for instance, there are mechanisms where you can say, okay, we require you to have an available version this is a product release. And so if anyone wants to do quote unquote an audit, it is actually literally, you would say, okay, this is this official release, right? And then you would go get that release and put that package in, right? It's just a binary, but you're officially getting that binary. I can get into a lot more detail around this because we have dealt with this question around machine learning, which is extremely susceptible to this exact problem. But there are certainly ways that the industry, you can respect the industry and their IP and still be able to get that benchmark, but it doesn't all have to be open source. And with that said, Victor, if you don't mind, Seven has had his hand up for quite a while. So I want to make sure we respect.
Yeah, hi. My name is actually Nolan Azzoni. I know it's kind of misleading there. I didn't see any way in Google Meet to be able to change that. I'm actually one of the UC analysts here at Edgewell Personal Care, and I know this is kind of is a bit of a digression, but I don't remember exactly the name of the person that invited me, but I figured there was something in my skill set that they thought I could contribute in some way. So I'm interested to learn more. I mean, I definitely took some notes. So
Okay. Welcome to the group, definitely. And yeah, I mean, it's an open group, so anyone can join, contribute. I don't know if if you managed to get it, but I'm gonna paste again the minutes in the chat. That's probably the best way to dig in. Just browse through the issues. We do maintain a community repo wherein there's a number of tickets. Do feel free to open new issues if you do feel that you have any new topic you can contribute to. That's how we operate, and that's as much as I can give you right now.
yeah, that's fine. I figured, with the mention of all these applications, maybe in what ROS or that's the use of software to improve the performance of existing hardware, right? Rather in lieu of maybe getting new hardware.
No, no. ROS is a robotics framework. It's essentially a series of tools as well as predefined libraries for building robotic applications. So I can point you. The best place wherein to maybe read a bit more about this is, and I'm going to share my screen real quick again, is this one. So this is the RobotPerf ticket that's linked in the minutes. And there's a section in here which says why ROS2, right? Because maybe many of you, like you yourself, might be asking why. Yeah, why are you guys like even mentioning this thing? Why aren't you just grabbing a robot and measuring it directly? Well, there's a number of reasons why ROS is so relevant in the robotics community and why we're using it, as well as why we're using it as the baseline for conducting measurements and benchmarks. And part of it is because it's widely used. It is pretty much used by the majority of the roboticists right now. And also it is because it is a common blueprint that people is kind of like leveraging to define new robotic computations.
I see. Okay, yeah, I'll definitely look into this a little bit more. Thank you. I'm actually still at work, so I got to get back to it. But yeah, thanks, guys. If I'm invited to the next one, I'll see you next time.
Sure, you are. All right. So I think any more questions? I think we have Jason in here still with us. Anyone else would like to ask him something?
Yeah, sure. Hi, this is Divya. So, hey, so I wanted to ask you from my experience of benchmarking some like applications which customer demand us to like write on top of the middleware, for example, how can I write like a very generic benchmarking framework which can accommodate doing actual work on the system, which the otherwise like a camera pipeline or a LiDAR stack, for example, in an autonomous driving situation, will be running some actual algorithms under the hood in the actual pipeline. So how can I simulate the exact behavior in like a benchmarking system when I am calculating latency or throughput of such a system?
All right, Jason, would you like to say something? Otherwise, I can give it a try.
Yeah, do you want to take this one?
Sure. So, so Divya, you're probably familiar with LTTNG and ROS2 tracing, right?
Right.
I mean, Christoph is with you guys, so
yes.
Yeah, he knows everything about it. Right. So my answer actually would be probably tied to if you want to be general and want to try to generalize across use cases in the automotive space, for example, which I know is the one you guys are touching on. So so of course, ideally, you want to have your different layers in your robotic systems instrumented. So all the way from your data link layer up until your layer 7 of the OSI stack. So of course, including the middleware. And then each one of the ROS2 layers. The ROS2 layers are fortunately already instrumented, and Christoph took care of that. But when it comes to the actual application itself, most application customers, at least that's our experience as well, are providing us and are writing. They don't come instrumented. They just don't. So the way you actually would approach this is, and let me give you a visual intuition about it, of how we are doing it. Here it is. So the way you would approach it is like this. And this is also in the REP 2014, but anyhow, this just comes handy right now. So this is how we do it ourselves. And the first thing that we do is we grab that piece, that application piece, and we instrument it first. And that allows us to generate kind of like a baseline compute benchmark, so to speak. And the way we do generate that benchmark is, again, by just collecting each one of those data points. And essentially just writing a Python script, a launch file. You can do it in ROS launch files directly. That's what we do. At least it's the handiest thing. And then literally digest each one of those data points and then produce whatever benchmark you want to. Maybe you want to report about throughput, or you want to report about latency or real-time compliance. That, I mean, the non-functional measurement you will be reporting on, or the functional one, is actually very tied to what you want to do itself. That's application specific, and again, that's down to you. But you can do it with each one of these data points, and each one of these scripts, unfortunately, is going to be tied to each one of these customer use cases. At least that's my experience so far. I don't think you can. I mean, you can reuse, of course, this logic and these scripts. But being general across completely different applications would require you to define a very strict hierarchy of trace points in the sense of namings and structure, and then go back to each one of those. We haven't reached yet that point of maturity ourselves. Maybe you guys definitely can help us define that and maybe use it as part of our ongoing efforts. But I think that might be a way to answer your interests. What follows actually after getting a benchmark is actually iterating on the design until you do reach your compute objectives. But you can disregard that if you're not using hardware acceleration, or if you are, you can of course iterate with that. But then again, this recipe.
That was my follow-up actually. Like if it's processing LiDAR or camera, like mostly 90%, 95% should be using hardware acceleration as of like today, somewhat in some sense. So how do you kind of isolate that part and do the tracing for it, or like measure the performance for that component running on the other hardware apart from the CPU?
Right. So typically what you want to do is you want to measure things in the host interaction. So in the interaction between the host and the accelerator device, that's wherein you want to measure things. So it depends on the compute architecture and the computational graph you're studying. It depends on what's being offloaded in the accelerator. Worst case scenario, you measure things in the host, so in the CPUs with LTTNG. Best case scenario, you actually integrate tracing capabilities inside of the accelerator. So there's some accelerators, for example, AMD GPUs have actually tracing capabilities, and you can integrate trace points directly into that, and that's something we're looking at. Then there is, for example, proprietary solutions that you can then leverage, which aren't LTTNG friendly, but you can still leverage from both AMD in their FPGAs as well as the NVIDIA solutions and also the Intel solutions. So each one of these have their own way to do tracing, their own way to collect data, and to give you introspection into what's going on in the accelerator. And they typically report also in kind of like a FAT file that gets dumped into the root file system. So the actual work in there for you would be to actually transform that into CTF, the common tracing format, which is the one that LTTNG uses. And you can do that. We've done that. It's just a bit of work.
But then, like, aren't we trying to prevent that in a way with this common robotics benchmarking system, like to prevent like vendor lock-in, and like everyone wants to create their own benchmarking framework and like bias it towards their own performance optimizations?
Yeah, totally. And that's what we are trying to prevent. And that's why we are trying to get as far as possible from each one of these vendor-specific tracing and benchmarking toolings, which I've used quite actively. For some of this, I'm still using some of them very actively, and that's what motivates us to push forward these standardization efforts that I mentioned around Rep 2014. So instead of having to really dive down into specific solutions, you would essentially look at things from a somehow vendor neutral perspective. And you can still do so, just to be fair. You can still do so while relying on CPU compute and tracing and putting trace points at the CPU, let's say, level. But again, if you want to if you want to get like really insights into multi-acceleration kernel interactions and so on and so forth, then you need to look into some of the proprietary tools, because that is still not integrated. Might be integrated in the future, but again, that is to be discussed and future work. If you anyhow would like to expand on this, I think a good reference for you is to take a further look at the Robot Core paper that I wrote with Sabrina, Brian, and BJ. We do discuss part of this in this section. So this is actually this is a thumbnail and a screenshot that shows one of these proprietary tools. This is the Vitis HLS analyzer. And you can see how in here we have information about the kernel compute time. So this is the acceleration kernel executing. And this is actually the overhead of the framework that's being used to convey the information from the host CPU into the accelerator itself. And you can see there's an overhead and so on and so forth. But this level of introspection may require you to rely on specific tools or interface these tools with LTTNG.
Okay. No, understood. That's very good. Very good to know. I'll go through this definitely. Yeah.
Yep. Okay. I think we went past 15 minutes of the time and still 50 folks in here. So thank you guys so much. I think we can close it in here. If anyone still has questions, feel free to use the community resources. Jason and BJ, I think BJ left, but Jason, thank you so much for a great presentation once again. Very much looking forward to work with you guys on RobotPerf. And to the rest of you, there will be a meeting in about a month, approximately, the last one this year. We're going to have, again, an exciting guest speaker and also funny new topics on hardware acceleration. Thank you, everyone, once again, and see you in about a month. Take care. Ciao, ciao.